Welcome back, folks. Now we're going to look into certain terminologies into the confidence interval. So if I can recall, when I talked about the confidence interval, we had a lower limit and an upper limit of our point estimate. So going back to the example which we did, we said the lower limit was 160 and 180 was the upper limit for the average height. And the average height mean value came out to be 170 centimeter for the sample which I calculated. Now, this 170 centimeter is called point estimate. Point estimate. And this is interval, confidence interval. As I previously said, it can be 95, 90, depending upon the what you are trying to figure out. Now let's see how we gonna find out the confidence interval, and before that we're gonna look into certain terminologies. So confidence interval, first of all, is always the middle portion from the mean. So if this is the mean value, which is, I will say, 170 centimeter, in this case it was, and the lower limit was 160 centimeter. Upper limit of this confidence interval was 180. Let me write it on top. So 160 to 180 centimeter. And let's assume that this confidence interval was 95%. We will talk about what 95% and 90% later on too. So this becomes the confidence interval. See, this region is the confidence interval, uh, the area I am shading. The area which I left out is called level of significance. This is the level of significance. Confidence interval is always the middle portion. So this is the middle 90% of the total region, and the remaining portion, as I said, is called level of significance. Level of significance. This region plus this region is level of significance. So if the confidence interval is 90%, level of significance in this case will be 10%. Okay, which in proportion terms I can call it as 0.1 also. And this one I can call it as 0.9, confidence interval of 0.9. Okay, level of significance is represented with term alpha, and this alpha is always divided over the two sections. So half is here, half is here. So this becomes alpha over 2, and this also becomes alpha over 2. Now what we're going to do is we're going to try and find out the probabilities across the given table. So if I am creating a 90% confidence interval, so this again redrawing the graph, this was 160, this was 180, and this alpha value was 0.1, or I can call it as 10%. So this value, this section is 5%. Can I say alpha over 2? This one is 5%, or I can also call it as 0.05. What does this mean? The probability at this particular point is 0.05. And if I ask you to pause the video and find the probability at this point, try and do that. So welcome back. So the probability at this point will come out to be 0.95. Why 0.95? Because if this is 0.05% of the section, this total section, as I said, we are doing a 90% confidence interval. So this is 90% or 0.9. So 0.05 plus 0.9 will become 0.95. This point is 0.95, and here it is 100%. Okay, so these are the probability values: 0.95 at this point, and probability of, well, 0.05 at this point and 0.95 at this point. So again, I'll sum it up. This alpha is called level of significance, and alpha is always divided into two sections, and half of the alpha is alpha over 2. So whatever the level of significance is, you have to divide it equally over the two sections, and then you will solve the questions. Now, let's look into a question based on whatever we've learned so far. So I'm going to go and take this example, which is on your computer screen. A study of 30 business executives found that on an average, executives spend 128.3 minutes each week responding to the emails. If the population standard deviation is known from the previous studies to be 15.2 minutes per week, calculate the margin of error and construct a 95% confidence interval for the true mean weekly uh, time that business executive will respond to these emails. So basically, we wanted to construct a 95% confidence interval uh, around our sample mean. The sample mean is 15.2 minutes. Now, before even I start solving this question, one more thing I wanted to tell you is this portion. When we were creating this confidence interval, the confidence interval in the previous example, we said that 170 was the average height, and the lower limit is 160, and upper limit is 180. So this value, which takes you to the lower limit and to the upper limit, is called margin of error. Margin of error, and it is represented by term E. Okay, look into your formula booklet. You will find the formula for margin of error. It's basically nothing new you are learning in this one. It's just you are just what shall I say, moving around the terms. It's a little bit of an algebra in the previous formulas you've learned. And one more thing, margin of error is always equal. If this is 10 on this side, it will always be 10 on the other side. It will not be different. Okay, because we always take the middle values. All right, let's go back into our example and try and solve this one. A study of 30 business executives found that on an average, executives spend 128 minutes each week responding to the email. The population standard deviation is known from the previous studies to be 15.2 minutes per week. So we are given that they spend about 128.3 minutes. So average time spent is 128.3 minutes each week responding to the emails. If the population standard deviation is known, uh, that is 15.2. Sigma is given to me 15.2 minutes, that is given per week. Calculate the margin of error. We wanted to calculate the E value first of all, and then construct a 95% confidence interval. So how are we going to create the margin of error? First of all, you can directly look into the formula, or you can say, you can always manipulate the terms by using the previous formula also. So Z value is equal to X bar minus mean divided by sigma upon square root of n. This is the same formula from chapter 8 which I'm using. Now if I move Z times sigma upon square root of n, if I do this, this thing is called uh, margin of error. Margin of error. So we're gonna try and calculate the E value from here. So to calculate the E value, first of all, I need to know the Z value, because standard deviation is given to me and N value is also given to me. The sample size is 30 business executive. So how I'm going to calculate the Z value first of all. So I'm going to draw the diagram for that. So if I draw the normal distribution graph, this is how it's going to look like. And in this one, my sample average is 128.3 given to me. and I am creating a confidence interval of 95%. So 95% confidence interval means the middle 95% of the region. So if this is the middle 95% of the region, this value will be 0.025 and this value will be 0.975, because this is 2.5% of the section. This section is also 2.5% of the section. If the total section from here to here is 100%, I can subtract 100% minus 2.5%, that is 97.5%. That is, if I divide that by 100, that's going to give me 0.975. So hopefully you are clear about how you're going to calculate these values. Now, if I try and find the values correspond to this 0.025 and 0.975, I'm going to get the certain z value. So I need to pause this video here, and because I forgot to uh, bring my uh, to put my z table in front of me, so I'll pause the video for a couple of minutes and I'll see you on the other. All right, welcome back, folks. So the z value which I figured out correspond to this point was negative 1.96 and correspond to this point was 1.96. Now correspond to this z point, I will try and do my calculations for the e value. So E is equal to 1.96. I can take the positive value because when you are moving to the left, you will subtract it from the mean. When you are moving to the right from the mean, you will add it to the mean value while creating the lower and upper limit. Okay, so E is equal to 1.96 times sigma, which is equal to, given to us in this question, that is 15.2, 15.2, and divided by square root of n value. N is equal to 30. So this value is 30 here. And now I'm gonna try and do the calculations. So the 1.96 multiplied by 15.2 and then divide this by square root of 30. That comes out to be 5.43. And I will look at the mean. Mean is only up to one decimal place. So I'll keep the margin of error also to one decimal place. That will be 5.4. E is 5.4. Once we calculated the E value, now we will try and calculate the lower limit and upper limit around it. So lower limit from 128. Let's see that. So 128 was the mean, So x bar minus e for the lower limit, and upper limit will be equal to x bar plus e. So x bar value is 128.3 minus 5.4, and upper limit is 128.3 plus 5.4. So if I were to calculate those values, this will be 128.3 plus 5.4, which is 133.3. Well, this should be the upper limit because I added it. 133.7, and 128.3 minus 5.4, that comes out to be 122.9. So the confidence interval, which I'm going to write here, so this will be written as x bar minus e less than mu, and this actually less than here, x bar plus e. Okay, so this value is 122.9, and mean less than 133.3. So what does this tell me? That I am 95% confident based on the given information. I am 95% confident that the true mean, what is the true mean? This is the true mean. True mean will True mean weekly time that the business executives spent on responding to emails will lie between these two values, 122 to 133.3. That's how we're gonna solve these questions. Now, when you are solving these questions, especially from chapter 9.2, look at it carefully. One thing you will find into the chapter definition also, that is creating the confidence interval when the standard deviation of the population is known. So whatever we are doing, it is important to understand, to solve these kind of questions, we need to have the population standard deviation given to us. Or sometimes, because as I told you earlier in the beginning, that we are making the prediction about the population. So if I know the population standard deviation, then it means at the background I have some sort of a data. So to in reality, it's very hard to have the standard deviation of the population. In that scenario, what happens is the sample size is so big that you can assume that the standard deviation you got from the standard deviation of the sample is approximately same as the standard deviation of population. So this is another thing. So either this piece of information is given to you that the sample size is so big that you can assume standard deviation of a sample is same as the standard deviation of population, or you will be given that the standard deviation of the population is known. Then you're gonna apply methods like this to create the confidence interval. So hopefully you were able to understand how you're going to solve these questions. Now the next question going to come to your mind, that what if the standard deviation of the population is not given to you, and on top of that, what if standard deviation of the sample is not same as the standard deviation of population? If these two assumptions are not there, means this assumption and this thing is not given to you, then what you going to do? To solve the question, we will move to another distribution that is called t distribution, and about that distribution we're going to learn in the next video. So hopefully you were able to understand how to solve the questions on chapter 9.2. that is creating the confidence interval when the standard deviation of the population is given to you. I'll see you with another video. Till then, goodbye.